Now next is, that is your, to prove that d over dx of x over 2 into under root of, this is a square minus x square plus a square by 2 into sine inverse of x upon a, and what we have to prove here is that it is under root of a square minus x square. So it is d over dx of x over 2 into under root of a square minus x square plus a square by 2 into d over dx of sine inverse of x over a. Because this being constant can be taken outside the differential sign, so half of first function into the differential of the second plus second function into the differential of the first plus a square over 2 into 1 over under root of 1 minus x square over a square into differential of, that is your x over a. So it is half of, it is x into 1 over 2 times under root of a square minus x square into d over dx of a square minus x square plus under root of a square minus x square into 1 plus a square over 2 into, what is that? It is 1 over under root of a square minus x square into a into 1 over a. This will cancel. So it is half of x over 2 times under root of a square minus x square into minus 2x, because differential of a square is 0, plus under root of a square minus x square plus a square over 2 times under root of, this is a square minus x square, this will cancel. So what is that? It is half of minus x square plus a square minus x square upon under root of a square minus x square plus a square over 2 times under root of a square minus x square. So you can see here I can take 1 over 2 times under root of a square minus x square common. It is a square minus 2x square plus a square. What is that? It is 2 times a square minus x square over under root of 2 times under root of a square minus x square, which is your under root of a square minus x square. So it's very easy to prove the questions or to find their derivative, provided that your basics are very strong as far as any topic is concerned. Now next is, say we have to find the differential of tan inverse of x by 2 and its root. So what is that? It can be written as d over dx of tan inverse of x over 2 raised to power half. It is n times x raised to power n minus 1 into d over dx of tan inverse of x over 2. So it is half of tan inverse of x over 2 raised to power minus half into differential of tan inverse is 1 over 1 plus x square into the derivative of, that is your x by 2. So it is 1 over 2 times under root of tan inverse of x by 2 into 1 over 1 plus x square by 4 into half. What is that? So it is 1 over 4 times under root of tan inverse of x by 2 into 1 over 4 plus x square by 4. So this is the answer here. Now similarly, say the next question is that if y is equal to e raised per x plus e raised per minus x, then what we have to prove here is prove that dy over dx is equal to under root of y square minus 4. First we will differentiate this. So dy over dx is equal to, it is d over dx of e raised per x plus e raised per minus x. It is e raised per x plus d over dx of e raised per minus x. It is e raised per x plus e raised per minus x into d over dx of minus x. Whatever additional function is there, that needs to be differentiated, because this is additional here minus x. So it is e raised per x plus e raised per minus x into minus 1, which is your e raised per x minus e raised per minus x here. Now because e raised per x plus e raised per minus x whole square minus e raised per x minus e raised per minus x whole square is equal to 4 times e raised per x into e raised per minus x. How do we get? Because a plus b whole square minus a minus b whole square is equal to 4ab. So it comes out to be equal to 4 here. Now from here you can see that what is this? It is y. Y square minus 4 is equal to e raised per x minus e raised per minus x whole square, or under root of y square minus 4 is equal to e raised per x minus e raised per minus x. So from first and second, dy over dx is equal to, this is under root of y square minus 4. Now next is differentiation of inverse trigonometric functions. Very important topic. While discussing this, I can say that I can assure you that I will explain 70% of the inverse trigonometry right now. Now, first question is differentiate sine inverse of sine x when x belongs to 0 to 2 pi. Now before discussing all this, let me discuss the principal value branches for your inverse trigonometric functions. Now principal value branches for inverse trigonometric functions are sine inverse of x, it is minus pi by 2 to pi by 2. Cos inverse of x, it is 0 to pi. Tan inverse of x, open interval minus pi by 2 to pi by 2. Cot inverse of x, that is your 0 to pi. Secant inverse of x, 0 to pi except pi by 2. Cosecant inverse of x, it is minus pi by 2 to pi by 2 except 0. So sine inverse of sine theta is equal to theta only if theta belongs to the principal value branches, that is your minus pi by 2 to pi by 2. And same is applicable for each and every inverse trigonometric function. Now the question is to differentiate this. So I can straightway say that because the interval the interval which is given to you is 0 to 2 pi. So y is equal to sine inverse of x. Sorry, it is sine inverse of sine x when x belongs to 0 to pi by 2. This will be equal to x because this is the subset of the principal value branch. So y is equal to x, therefore dy over dx is equal to 1. Now when it does not lie in the principal value branch, for example the next case, then what to do? Second case is when x belongs to pi by 2 to 3 pi by 2. Why we have added from pi by 2 to 3 pi by 2? Because for every inverse trigonometric function within the interval of pi, you are going to get the same result. So that means minus pi by 2 to pi by 2, then you add pi to it, pi by 2 to 3 pi by 2. So you have to restrict by adding pi to each and every that is for each and every inverse trigonometric function. Now my tendency should be to bring this interval in the principal value branch. So how can we do that? Now if I multiply it with a negative sign, can I say that minus pi by 2 is greater than minus x is greater than minus 3 pi by 2? That is, minus 3 pi by 2 is less than minus x is less than minus pi by 2. You add pi to it. Minus 3 pi by 2 plus pi is less than pi minus x is less than pi minus pi by 2. That is, your minus pi by 2 is less than pi minus x is less than pi by 2. Now this angles belongs to the principal value branch. Now further, sine inverse of sine x can be written as sine inverse of sine of pi minus x. How can we write? Because sine 180 minus theta is sine theta. This is the angle which belongs to principal value branch, so this is equal to pi minus x. Now y is pi minus x. Then what will be dy over dx? It will be equal to minus 1 here. Right? So whenever we have to differentiate inverse trigonometric function, when the corresponding range is given, so we have to bring the range within the principal value branches. Like in this case, after that you differentiate it, you will get the answer. Now still this is your first and this is your second. Now come to the third one. Third is when after second. Third is when x belongs to 3 pi by 2 to 2 pi. Again you can see that this is not the principal value branch here. Now if I add minus 2 pi to it is less than minus 2 pi plus x is less than 0. Minus pi by 2 is less than minus 2 pi plus x is less than 0, which is the principal value branch. Also sine of minus 2 pi plus x is minus sine of 2 pi minus x, which is your minus into minus sine x, which is your sine of x here. So that is, this is your sine x here. So therefore y is equal to sine inverse of sine x can be written as sine inverse of sine of minus 2 pi plus x. This angle belongs to the principal value branch, is equal to minus 2 pi plus x. So what is dy over dx? This is equal to 1 here. So for each and every question, this way you will bring the given range in the principal value branch, only then you can differentiate the function. So straightway you cannot say that the answer of this question is always going to be equal to 1. You can see that it's not always equals to 1. Now next is, for example, differentiate sine inverse of 2x into under root of 1 minus x square. Now under the three different cases, first is when x belongs to minus 1 over root 2 to 1 over root 2. Second case, when x belongs to 1 over root 2 to 1. And the third case is when x belongs to minus 1 to minus 1 over root 2. Now from first, because there is a one term of the form a square minus x square, in that case we will always put x is equal to a sin theta or a cos theta. So from 1 put x is equal to a, in this case is 1, so sin theta. So let y is equal to this. Therefore y is equal to sine inverse of 2 sin theta into modulus of cos theta. Why I have put the modulus? Because the conditions are given to me. Now from first, x belongs to minus 1 over root 2 to 1 over root 2. that is sin theta belongs to minus 1 over root 2 to 1 over root 2. That is theta belongs to minus pi by 4 to pi by 4 here. Since mod of cos theta is positive when theta belongs to first quadrant and the fourth quadrant, so therefore from 2 y is equal to sine inverse of 2 sine theta into cos theta, which is your sine inverse of sine 2 theta. From third, 2 theta belongs to minus pi by 2 to pi by 2. So this is fourth, this is fifth. So from fourth and fifth, y is equal to 2 theta. Why? Because 2 theta belongs to the principal value branch. What is theta? So from A, theta is equal to sine inverse of x. Therefore y is equal to 2 sine inverse of x, or dy over dx is equal to 2 over under root of 1 minus x square. The steps will automatically come to your mind if you are very thorough in your let's say results or in their proving or in their fundamentals. If you are very thorough, you are not going to have any problem. Now come to the second case. From second, x belongs to 1 over root 2 to 1, sine theta belongs to 1 over root 2 to 1, theta belongs to pi by 4 to pi by 2, or 2 theta belongs to pi by 2 to pi. Now this is not the principal value branch, so we have to bring this interval in the principal value branch. Can I straightway write this as, if I multiply this inequality with a negative sign, that minus pi is less than minus 2 theta is less than minus pi by 2? Can I straightway write this? Now adding pi to it, 0 is less than pi minus 2 theta is less than pi by 2. So therefore from, what is that, it is 4, y is equal to sine inverse of sine of pi minus 2 theta. It is pi minus 2 sine inverse of x, or dy over dx is equal to minus 2 over under root of 1 minus x square. Now from third, which is your minus 1 is less than x is less than minus 1 over root 2, that is sine theta belongs to minus 1 to minus 1 over root 2, that is minus pi by 2 is less than theta is less than minus pi by 4, that is 2 theta belongs to minus pi to minus pi by 2, but it is not the principal value branch here. So if I add pi to it, now it becomes 0 to pi by 2, although it belongs to the principal value branch, but sine of 180 plus 2 theta is equal to minus sine 2 theta. To absorb this negative sign, I can write this as minus pi by 2 is less than minus pi plus 2 theta is less than 0. So therefore y is equal to sine inverse of sine of minus pi minus 2 theta, which is your minus pi minus 2 theta, minus pi minus 2 sine inverse of x, or dy over dx is equal to minus 2 over under root of 1 minus x here. So this way you can solve the questions relating to, that is your inverse trigonometric functions. Now next is to differentiate tan inverse of a plus x over a minus x. Now because tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy. So always keep one thing in your mind. The formula for tan and tan inverse, in all these formulas always it should be 1 at this place. So to get 1 at this place, dividing the numerator and denominator with a. So y can be written as tan inverse of 1 plus x over a over 1 minus x over a. So can this be written as tan inverse of 1 plus tan inverse of x over a? So which is your pi by 4 plus tan inverse of x over a? What is that? It is y. So what is dy over dx? 0 plus 1 over 1 plus x square over a square into d over dx of x over a. It is 0 plus a square over a square plus x square into, what is that? 1 over a, which is your a over a square plus x square. This is the differential here. Similarly, let's say we have to differentiate. The next one is tan inverse of x over 1 plus 6x square. Can I write this as it is 1 plus 3x into 2x? Can I write this as tan inverse of 3x minus 2x over 1 plus 3x into 2x? So which is your tan inverse of 3x minus tan inverse of 2x. Why? Because tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y over 1 plus xy. So if you straightway differentiate all these functions, maybe your teacher is not going to give you any marks for that. So you have to use the properties of the inverse trigonometric functions to differentiate them. So here it is y. What will be dy over dx? It is d over dx of tan inverse of 3x minus d over dx of tan inverse of 2x. What next? It is 1 over 1 plus 9x square into 3 minus 1 over 1 plus 4x square into 2. So this is the differential of your function here. Now next is to differentiate tan inverse of under root of 1 plus a square x square minus 1 upon ax, because this is of the form a square plus x square. We will always put x is equal to a tan theta or a cot theta. So in this case, put ax is equal to tan theta. Can I write this as tan inverse of 1 plus tan square theta and its root minus 1 upon tan theta? What next? It is tan inverse of 1 plus tan square theta is secant square theta. It is secant theta minus 1 upon tan theta. It is tan inverse of 1 minus cos theta upon sin theta, which is your tan inverse of 2 sin square theta by 2 upon 2 sin theta by 2 into cos theta by 2. So this is your tan inverse of tan theta by 2, which is your theta by 2, which is half of theta from here is tan inverse of ax. This is y. What is dy over dx? It is half of 1 over 1 plus a square x square into d over dx of ax, which is your a here. So this is the differentiation of this particular function here. Now, for example, the next one is to differentiate tan inverse of 2 raised per x plus 1 upon 1 minus 4 raised per x when x belongs to minus infinity to 0. So this is the condition which is given to us in this case. Now, can I write this as tan inverse of 2 into 2 raised per x over 1 minus 2 raised per x and its square? So why I have written in this case? Because 2 tan theta over 1 minus tan square theta, which means that 2 raised per x is equal to tan theta. So this becomes tan inverse of 2 tan theta over 1 minus tan square theta, which is your tan inverse of tan 2 theta. This is first and this one is second here. Now because x belongs to minus infinity to 0, 2 raised to power x belongs to 2 raised to power minus infinity to 2 raised to power 0. 2 raised to power minus infinity 0 is less than tan theta is less than 1, or this implies that theta belongs to 0 to pi by 4, because here the angle is 2 theta. 2 theta belongs to 0 to pi by 2. So therefore from second and third, y is equal to 2 theta, which is your 2 times tan inverse of 2 raised to power x. Now how to differentiate this? Dy over dx is equal to 2 times 1 over 1 plus 2 raised to power x square into d over dx of 2 raised to power x. So it is 2 over 1 plus 2 raised to power x square into 2 raised to power x into log of 2 to the base e. So this is the differential of, that is your tan inverse of 2 raised to power x plus 1 over 1 minus 4 raised to power x.